An angle is, it says, formed by two rays. So when you look at two rays are just those, the two lines that go on one side. It's not a line because it doesn't have the arrow on the other side. So two rays form an angle with a vertex as the end point of the two rays. So when you draw that, you want to make sure this is just drawing an angle. In here, this is a ray, this is a ray, and then this is obviously your vertex, and then your angle is the part in between. So you can kind of label that on there. So you know that you have your two rays with the same endpoint, and the vertex is the endpoint of the angle, and the angle is obviously the degrees in between those two rays. Standard position, so when the vertex of an angle is at the origin and one ray is on the positive x-axis. So here is standard position for an angle. So let me give you an example. Right here is where all angles start. It says on the positive x-axis. So all angles will start right there, and then if it's going down, we'll have what's called a negative angle. If it's going up, we'll have what's called a positive angle, but they're all going to start in standard position, and that means that one of the rays will be going there, and you'll have your vertex in the center. Now, when you have your vertex in the center, the angle can still be, let's say that it's like 130 something, let's say 135 degrees, because that's an easy one to see. So there's 90. Like 135 degrees would be right here, and it would tell you that this is the angle that we're looking for. Okay, so that's just an example of drawing an angle. And this one's actually about, like I said, it's about 135 degrees. All the way around a circle, remember, is 360. But we always start the angles in that, on that right side, in standard position. That's what's called standard position. So what we were just talking about is the initial side of the angle. So let me draw it again, the same angle. If we draw that 135, this side right here is the initial side. It's the side that's in standard position. Initial means where you started at, your initial starting point. That means that's where we started. That's the beginning. The terminal side, terminal is where you end at, right? So initial is where you begin, terminal is where you end. So if we were looking for the terminal side of the angle, it would be that other one. So these are just, at the beginning, these are just vocabulary words. Again, it's that important vocabulary. It's important to know angle and vertex, which you should have already known before. It's important to know where an angle standard position is on a coordinate plane. It's important to know the initial side of an angle and what the terminal side of the angle is. Because it's going to ask you, a lot of times, so the initial side of the angle should be the same, regardless of what you're drawing. It should always be right there in standard position. It's going to ask you where the terminal side of the angle ends. And we're going to have to know the quadrants too, like what's quadrant 1, 2, 3, and 4 on the coordinate plane. And we'll go through that, I'm sure, as we move forward. All right, so I'm going to move down to positive and negative angles, the quadrants, and then an example for example 1. So let me move down. First of all, a positive angle is an angle with a degree greater than 0. So here's what we're talking about when we talk about positive angles. It's going to be, you have your coordinate plane drawn for both of these, whether it's positive or negative. Okay. You have your initial side, which is your standard side. You have these for both, whether it's positive or negative. You always have what's called the initial side. Now, if it is a positive angle, you're going counterclockwise, which means we could go all the way here and then stop. That's a positive angle. That one is actually, and you could count up how much they would be. That's 90, 90, that's 180. So it's somewhere 200 and something degrees. You could look, it would tell you what it would be. A negative angle could be at the same spot, but it will show that you're going counterclockwise or clockwise. What I like to think of it as is if you have a positive angle, it starts from the initial side by going up. So that's positive because it starts by going up. You see all you got to do is check the mark right here, and that's going up. A negative angle starts right here by going down. So even if they end at the same point, this is a negative angle. So you would add up how much it is negative. This is a positive angle. There's a difference between those. Even though they may end at the same spot. So a negative angle starts by going down. That's in the clockwise direction. A positive angle starts by going up. That's in the counterclockwise direction. So there you see the difference between the two. And so now in example 1, you want to draw four different angles. So we're going to look at 2 that are negative and 2 that are. Ask you to draw a 70-degree angle, and then part B is negative 135, C, D, so on. All right, so in part A, so a 70-degree angle, we know that is going to be less than 90. Obviously, this is 90, so we would try to find one that's a little bit less than 90. It's a positive angle, so we start by going up, and we just say there's 70 degrees. Okay, so that's a 70-degree angle. Don't have to be perfect. Nothing perfect about it. A negative 135-degree angle. So we have to think about it a little bit. We're going negative, which means we're going down. So when we go down, there's 90. So now we're at negative 90. If we went all the way here, we would be at negative 180. So negative 135 is about halfway right there. So that would be negative 135 degrees. You would have 90 and then 45 more. So it's a negative 135-degree angle. The next one is negative 31 degrees. There's your initial side. And think about it, we're going negative, so we're going down, not very far, and there's 31 degrees. So it's just part of that quadrant. And then 117 degrees. Again, we always start by drawing our vertex and the initial side. There's 90, a little bit more than 90 would give us 117. So all you're doing is going around to 360 to try to see how far the angle goes. Now, we do want to know what quadrants. They're going to ask you what quadrant that the angle ends up in. If the angle is from, so these are quadrants, so they go in order, right? Starting with positive. So think about a positive goes around this way, right? So quadrant number 1 is the first one a positive would hit. And as it goes all the way around, you get from quadrant 1 to 2 to 3 to 4. It just takes you all the way around the circle, right? So quadrant 1 is when an angle is between 0 and 90 degrees. Okay, we're going to go back and look at the negatives in just a minute. But that makes sense. If the angle is between 0 and 90, it's in quadrant 1. When the angle gets to be between 90 and 180, it's in quadrant 2. Between 180 and 270 is in quadrant 3. And between 270 and 360 is in quadrant 4. So if you look at the 2 positive ones we did, in A, the 70-degree angle is in quadrant 1. It's between 0 and 90. The 117-degree angle is in quadrant 2 because it's between 90 and 180. So now we also want to look at the negatives. So we want to start by going down. So quadrant number 4 would also have angles that are between 0. Well, I should do it this way. Between negative 90 and 0. So if you think about it, if you're going down, between 0 and negative 90. Quadrant 3 would be from negative 180 to negative 90. So if you think about that, negative 90 to negative 180. Then here would be from negative 180 to negative 270. And then from negative 270 all the way to negative 360. So basically, it's basically the opposite. You're going around the other way. So again, think about it. You're just thinking about negative. This is 0 to 90 negative. This is 90 to 180 negative. This is 180 to 270 negative. And it's 270 to 360 negative. So it's either positive in the counterclockwise direction or negative when you're going clockwise. So those are all your quadrants. So sometimes they're just going to give you the measure of an angle and just say what quadrant is the terminal side in. So we see in B, negative 135 degrees. That's in quadrant 3. And then C, negative 31 degrees is in quadrant 4. So you're able to find where those negative angles end up. Means that a coterminal angle means that it is on the same spot on the coordinate plane. So basically, if you are standing in one position and you turn around in a circle, you're still standing at the same position, but you moved, right? If you have, and that's what happens with these angles. So a coterminal angle, if we want to find a positive coterminal angle, we add 360 to the current angle. Okay? So if I'm standing, if you think of the floor or whatever as an angle or whatever, if I'm standing at, this is 0, if I'm standing at 90 degrees, and then I just turn all the way around in a circle, then that just added 360 to it. So now I'm at 450 degrees. Still, that's a coterminal angle. So it means I'm still at the same position. I'm still looking in the same direction. I just added 360. To find negative coterminal angles, we're going to do the same thing. We're going to subtract 360. So since 360 degrees takes you all the way around the circle, then to find positive and negative coterminal angles, all we have to do is add and subtract that 360 degrees. So, to look at the first, so I can give you, we can talk about it in a minute, but I'll give you an example. So it says find two positive, so this one says find two positive coterminal angles with negative 410 degrees. So first of all, we want to find positive coterminal angles. That means we want to add 360. The problem here is it's negative 410. Right, so when we add 360 degrees, we still end up with a negative, right? So we end up with negative 50. That's not enough. That's not good enough. So it's still, because it said find two positive coterminal angles. That's a negative coterminal angle. So it is possible that the number is so far negative that when you add 360, you still get a negative coterminal angle. So we just have to add 360 again. It's just like going in a circle again. And so now we're at 310 degrees. And so that is a positive coterminal angle. If we want to find another one, we can add 360 again, and we are at 670 degrees. Now I can show you on the graph what that looks like. So let's think about it. So negative 50, so negative 410, this is going to be a little crazy looking, but negative 410 looks like this. It goes down, goes all the way around one time, that's 360, and then about 50 more, so maybe right here. Okay? Starts to look like it hypnotizes you. That's negative 410 degrees. Follow it from the inner circle. So it starts right here, and it goes down. That tells you negative. And it goes all the way around the circle. That's 360, and then about 50 more.
How do we know where it starts?
From the inner part right here. It always starts in the standard form. You look at the inside line.
So it doesn't matter if I started at 2?
Oh, it does, the number doesn't matter. No, those numbers mean nothing. So you start on the inside, and then as you go around, you get outside. So really, you can get like 1,000-something degree angle, and you can go around and around and around and around. And we could have a coordinate plane that goes like,
Oh,
right, I mean, it could keep going forever. Every time it goes around is 360. But what they're trying to show you is this is negative 410. But also think about it. If I just went down one time, this is also negative 50. Okay? If I went the other direction, if I went positive, this is also 310 degrees. It's in the same spot as me going 310 degrees positive. And if I went all the way around the circle 360 and then 310 more, this is also the same as 670. So what they're showing you there on that graph, the negative 410 degree angle is in the same position as the negative 50 degree angle, as the positive 310 degree angle, as the 670 degree angle. So that's what it means to be coterminal. It means they're in the same, they end up, the terminal side, coterminal, share, terminal, ending point, means they share the same ending point. There's your English lesson. So B, find two negative coterminal angles to 579. So we're just going to subtract 360 until we get there. So 579 minus 360 gives you 19? And then we're still positive, so we've got to subtract 360 again. So now we get to negative, is it 141?
yeah.
Okay. And we want another negative. So negative 501. So again, all we're doing is adding and subtracting 360. In A and B, we had to do it twice. We don't always have to do that, but A had such a big negative that we had to add 360 twice to get the positive coterminal angles. And B had such a large positive that we had to subtract 360 twice. So it doesn't matter how many times you add or subtract 360 to get there. It's just that's what we're doing. C, find one positive and one negative coterminal angle with 227. So 227 plus 360 will give us a positive coterminal angle, and 227 minus 360 will give us a negative coterminal angle. So what's the positive? And then the negative one, 227 minus 360 is negative 133. All right, so there's our two, that's our positive and negative coterminal angle. And again, we get that from adding and subtracting. D, another way they could ask you a question, they could say, find the measure of an angle between 0 and 360 with negative 321. So if you are at negative 321 and you want to find a coterminal angle with that, what would we do between 0 and 360? We would add, right, because it's negative, so we're going to add. And that coterminal angle is 39 degrees. And those are coterminal angles. You don't have to make it any harder than it is. You're always adding or subtracting 360. Okay? E says find the measure of an angle. So E is not on the board, but it's there. Find the measure of an angle between 0 and 360 with 1054. So we're going to have to subtract 360 once, and that's not far enough. That would give us 694. And then we have to subtract 360 a second time. When we subtract it a second time, we get to 334 degrees. So that should be your angle between 0 and 360, right? So in D, we had to add because we were a negative. In E, we had to subtract. And not only do we have to subtract, we had to subtract twice. Okay? So now, we will go to reference angles. It's kind of like a reference point. It'll say, this is how close you are to where, like, the courthouse is like a reference point. Like, here's where you're at compared to there. So reference angle is how far, in this case, the goal is to right here. How far is the terminal side from the x-axis? Okay? So how far is the terminal side from the x-axis? So 2 things. That means number 1, it's always going to be a positive answer because we want to know, because we're looking at a distance, how far away it is from the x-axis. We're not looking at is it positive or negative. It's how far away is it. So it's always going to be a positive answer for your referencing. Also, think about it. It doesn't matter which x-axis. The x-axis is on both sides. So if my angle ends up on this side, I would go see how far I am from here. If my angle ends up on this side, I would see how far I am from here. So my reference angle is always going to be, what's the biggest a reference angle could be, anybody know? Yeah, it's a number. What's the biggest number the reference angle could possibly be? Like if my angle ends right here, how far is it from the x-axis? If my angle ends right here, straight up and down, how far is it from the x-axis in degrees? 90 degrees, right? If it ends over here, it's somewhere less than 90 degrees from the x-axis. If it ends over here, it's somewhere less than 90 degrees. If it ends here, it's less. So the biggest my reference angle could ever be is 90 degrees. So if you answer a question for reference angle and your answer is over 90 degrees, you did it wrong. Okay? If your answer is negative, you did it wrong. So the reference angle is a positive number that's between 0 and 90. So let's look at it. It says sketch a graph of each of the following in standard position. Be sure that your swoosh marks, that's going around and around, match the number of turns around the unit circle and then find the reference angle. All right, so the first thing we do is make our standard form. It says negative 460. So we're going to start here. We're going to go all the way around. So now we've hit 360 degrees, right? And 90 more than that would be 450 degrees. And so we need about 10 more. So about right here. Okay? So remember, that is 10 degrees right here. From there to there. I just kind of marked that. Just so you know. So negative 460 takes you all the way around 360, 90 more, and then 10. So how far am I from the x-axis? It's not a trick question. 80 degrees. Because there's 10 right there. And each quadrant is 90. So I'm 80 degrees away. My reference angle is 80 degrees. I'm 80 degrees from the x-axis. The farthest I could ever be from the x-axis is 90, and that's if it's straight up and down, if it's a 90-degree angle, okay? All right, 553. We make our standard position, okay? We're going positive. So we're going to start here. We're going to go up. All the way around one time is 360. So that's easy. So going all the way around 360. I'm going to go 90 more. Now I'm at 450 because I did 90 more. I'm going to do 90 more than that. Now I'm at 540. And then I'm going to do 13 more. I'm at 553. I'm going to mark it so that I remember how far I went. 13 degrees. Okay, so I went 13 degrees right there. So how far am I from the x-axis?
No.
It's a trick question.
80.
13 degrees. That's how far I am from the x-axis. It ended right here.
Oh, yeah.
Here's the x-axis. I'm 13 degrees away.
Is it because it's a positive?
No,
Like,
it's just how far, it's just where it ends at.
Oh,
Yep.
because if it went a little bit farther and it went to the section 4, it would have went to the other side.
Yes, absolutely.
Oh.
Yeah, it's like
So it's how far, if you're on this side, if your terminal side ends over here, you're always going to this x-axis. If your terminal side ends over here, then you're going to this x-axis. Yep. So it's just how far are you from the x-axis. So negative 1,000, okay? Negative 1,000. Start here. Negative means we're going down, so 360. There's negative 360. We're going to go around the second time. 720. Okay, if we went 3 times, it'd be 1,080. So I know I'm not going 3 times. So I'm at 720. I'm going to do 90 at a time. Now I'm at 810. Now I'm at 900. Now I'm at 990. And 10 more. So I'm going to mark it that I did 10 here. So I know that's 10 degrees. And there's my angle. How far am I from the x-axis? 80 degrees. Yeah. That is 80 degrees is my reference angle. Okay. Now do positive 1,000. I'll let you try that one real quick and then I'll come back. Positive 1,000 degrees. We're going to do kind of the same thing we do with negative 1,000, but we're going to go in positive direction. So we will say, I'll start in the middle. You always want to start close to your vertex when you know you're going to have to go around more than one. So there's 360. There's 360 more. Now I've gone around twice, so I'm at 720. And then we say 90 more, that's 810. 90 more, that's 900. 90 more is 990. So then I have 10 right here. Okay, so there's my angle. So how far am I from the x-axis? 80 degrees. It's weird that we had 80 3 times. It's not going to happen all the time, but that's just what happens today. Now, you should also be able to know these kind of without graphs too. So, like you can try, if you have to graph it, that's fine, but you can be able to do it without graphs. So if I'm a 160 degree angle, if it's a 160 degree angle and you want to know the reference angle, you're saying how far is it from 180? 20 degrees. Okay. If it's a 290 degree angle, you're saying how far is it from 360? 70 degrees. So you can use coterminal angles. So for instance, 1,000. Let's think about 1,000. 1,000 minus 360 is 640. Okay? 640 minus 360 is 280. So a 1,000 degree angle is really a 280 degree angle, which means it's in quadrant 4. A 280 degree angle we would be seeing how far is it from the x-axis. Well, it's 80 degrees because the x-axis is 360. So it's only 80 degrees away. Now, if you had an angle like this, 553, well, 553 is really, if you subtract 360, it's really just 193 degrees, right? So 193 is in quadrant 3, and you're saying how far is it from the x-axis? That means how far is it from 180? It's 13 degrees from 180. So you actually don't have to have the graphs to tell what the reference angle is. You use coterminal to help. Like negative 460, you add 360, you got negative 100. Add 360 again, you've got 260. 260 is in quadrant 3, and you say how far is 260 from 180? It's 80 degrees away. So coterminal and reference angles can be used together, which is why they're taught in the exact same lesson. That's kind of how it showed you how you would use those two things together to solve the problems. So today, we get to try to solve problems with coterminal and reference angles. That's all we're really going to deal with is those two.